What does it mean when we say that something has a significant impact on something else? Well, we are making claims of causation. We're saying that variable X caused variable Y. But how can we make such claims? Well, this is where some statistical and mathematical principle comes in, and this is what I'm going to talk about today on Trees Philosophies. Welcome, everybody. This is Trees Philosophies, where this is where I go deeper in my thoughts, values, meditations, philosophies. People always tell me I go too deep. Well, I go deeper, baby. Anyways, let's get into it. So I'm going to take the idea of significance and causation. I'm going to link them together. And if by the end of this video, it makes sense to you, please give this video a like, share it with somebody that might also find value in it, and subscribe to the channel if you haven't already done so. So the term significance and a significant impact has a very specific definition when it comes to the scientific application of it. However, the same level of rigor isn't taken when media, journalists say that, oh, this has a significant impact on this other thing. Well, it has a specific definition. I'm going to go into what that actually means, because when we say that something has a significant impact on something else, we're making claims of causation. But sometimes when we see a change in variables, this isn't due to causation, but rather due to correlation. For example, imagine a hypothetical scenario where a bunch of people were to eat broccoli and this would lead them to have a breakout in pimples. So you might assume that broccoli consumption is leading to increase in pimples. However, again, we go back to the principle that correlation does not equal causation. So how would you actually get to the point of demonstrating causation? Because essentially you're saying that just because a variable X changed and this resulted in a change in variable Y, this does not necessarily mean that variable X caused the change in variable Y. So we can only make such claims when we do the statistical analyses that are necessary in order to do so. And this is where the idea of statistical significance comes in, where you must demonstrate a significant impact in order to then claim causation, that variable X caused variable Y. Now, let me give you an example to illustrate. So imagine if you were to measure your height and the height of everybody in your city. Some people would be on the shorter end, other people would be on the higher end, most people would be in the center. And if you were to create a chart that plotted the frequency of occurrence of each height, you would get something like this. And this is called the normal distribution curve. Looks like a bell curve. And it's called normal because almost any population measured for almost any variable will look like this. It's one of those fun mathematical constants. So we have our normal population, is what it's called. Now, what if you wanted to create a hypothetical potion, right? A magic potion, and you could claim that my potion has a significant impact on increasing people's height, right? So if you take my potion, there is definitely going to be a causal effect on your height. So my potion is going to cause your height to increase. Well, now, okay, we're going back to this idea of showing statistical significance in the impact. So how would you be able to make such a claim? So imagine you got somebody and they would take your potion, lucky participant number one. So they take your potion and they grow to be 6'1". Could you say that the potion had a significant impact? No, because when we look at our normal population, this is not an abnormal height. When we get to the idea of an abnormal height, we look at our normal population, right? Our normal distribution curve, and we come to the idea of a certainty range, right? Essentially, we say that there is a confidence interval, more accurately, a confidence interval within which that you can demonstrate that 95% of the population will be found within. So in our hypothetical population, our 95% confidence interval is between 5'6" and 6'4". So we can say that if we're to take any random person off the street, there's a 95% chance that they will be found within this range, either within 5'6", 6'4", right? So our confidence intervals allow us to identify populations. So when we go back to the example of somebody that's 6'1", they would be a little bit greater than the mean. However, they would not be outside of the 95% confidence interval of the general population. And you can only claim a significant impact when the result, right? The thing that you're measuring is outside of this 95% confidence interval of the general population. So, unfortunately, our friend that's 6'1", we could not say that the potion had a significant impact on their height. Now, imagine a second example where we had somebody else that took the potion and they grew to be 6'11", right? Now we can see that 6'11" is actually outside of the 95% confidence interval of our general population. Now we could say that, oh, in fact, our magic potion did cause the increase in height. So there's a causal behavior because there was a significant impact. Now, of course, you would need to reproduce this measurement on several occasions because one of the fundamental tenets of science is reproducibility. So you do this over and over and over again, and you take the mean and you see that the mean is still outside of that 95% confidence interval. Now you can say with a high degree of certainty, 95% certainty, in fact, you could say that your magic potion is causing an increase in height. So again, you can see that a lot of work needs to be done before we can say that something has a significant impact on something else, because this implies not just merely correlation, but causation. And again, causation can only be demonstrated when you have your population compared to the general population, and whatever you're measuring measures outside of that 95% confidence interval of that general population. I think this is really important to be aware of because we often hear in media, in news, people making claims of something causing something else. Well, then our first question should be, did they take the proper steps in order to demonstrate true causation? Did they demonstrate statistical significance? Were their measurements outside of the 95% confidence interval of the general population? Now, of course, there's much more maths and statistics that go into this, and I had to simplify it to demonstrate the idea, but I hope that it made sense to you. So again, go back to the idea of causation, significance. I hope I was able to link those to you. And if I was, please give this video a like, share it with somebody else that might also find value in it. And if you like this video, I think there's this other video right here that you might also appreciate. I'll catch you on the next one. Trees Philosophies. Peace out, guys.